Good morning everybody. So today's topic will be decimal to binary conversion and vice versa, means again binary to decimal conversion, but we are going to consider the fractional part also. First, what are the topics that we are going to discuss? Why do we need conversion first, and next we will discuss about the converting from decimal to binary and then binary to decimal. Right? So first, why we need to consider the conversion from binary to decimal, or let it be decimal to binary. First, why we need to consider these conversions we are going to discuss. Like it was discussed in the previous video, we humans, we have 10 fingers. So we have been widely using decimal number system because it is easy to count on our fingers. So we humans have been widely using decimal number system because of 10 fingers. Now computer, the switch, the fundamental switch, within the computer, we have discussed in the previous slide that a computer has billions of tiny switches called transistors. Now the switch has only two possible state. You have been using switches in your home. Switch can either be on or it can be off. Likewise with the tiny microscopic switches within the computer, the switch can either be on or it can be off. Only two states are possible. Hence computers, they use binary. So we need to consider the decimal to binary or binary to decimal. Reason being, we are giving task to the computer. Computer is not, we are giving in the decimal domain. Computer is not going to operate in decimal domain. So we need to first design, if you are a computer designer, first you need to design the conversion from decimal to binary. So now you will design the circuits which perform the computation in the binary domain, and then next level, again the result, if suppose 3 into 5, you get something like 0, 0, 1, 1 something, a series of zeros and ones, it is difficult for us to interpret. So that is the reason we need to convert the numbers, the binary numbers, back to decimal. So that is the reason both conversions are very important, decimal to binary or vice versa. Fine, right? So that is the reason we have to consider the conversions. And why we need to consider fractional part? If you see, suppose somebody will ask you what is your gate score, maybe you will tell 97.26 percentile. What is your intermediate percentage? Maybe you will tell 84.2. So point, the fractional part also we are using in our day-to-day basis. And you are also giving, suppose you want to find out what is the average percentage of the entire class, then one could have 67.26 percentage, another could have 84.2 percentage, another could have 96 percentage, and you have to take average of all these fractional parts also. We will use computers to make our job easy, right? So at the initial level, you should have a mechanism where we convert the decimal numbers, including the fractional part, into the binary domain and perform operations in the binary domain, and then convert back the binary number with fractional part, again we convert back to the decimal domain. So that is the reason in today's class we will discuss all these. So first, binary to decimal with fractional part. So in the previous class we have only considered the binary number to decimal without considering the fractional part. Right? So now here the additional extra fractional part is this. Fine? Now here if you see this part, the same computation which we have seen in the previous video, we can use it. Okay, so what we did in the previous video, we have taken the weights. Okay, we have taken the first, we have taken the binary number as it is, and then we have taken weights 0, 1, 2, 3, 4, 5. Okay, the last digit stops here. So we are taking 0 to 5, and in the previous video we have discussed that we will take in powers of 2 because we have to continuously multiply by 2. Okay, so that is the reason here we are taking weights, okay, 0, 1, 2, 3, 4, 5, but in the powers of 2. Okay, 2 powers, right? So what we are doing, we are taking 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. Fine. Now what you need to do here is, like we have done in the previous case, the first digit into 2 power 5, that gives us 32. 1 into 2 power 5, 2 power 5 is 32, 32 into 1 gives us 32. Okay. Next case, 1 into 2 power 4, 2 power 4 is 16, 16 into 1 gives us 16. Okay. Next case, 0 into anything, we don't need to compute what this is. Okay, we don't need to compute what this is, right, because 0 into anything is going to give us 0. Likewise, 0 into anything, doesn't matter what this is, 0 into anything is going to give us 0. Okay, right. Next, now 2 power 1 is 2, 2 into 1 gives us 2. Next, 2 power 0, anything power 0, you know it is 1. So this is 1, right, and 1 into 1 gives us 1. Fine. Now suppose if we didn't have this part, if the question only said 1 1 0 0 1 1 to the base 2, then you don't need to write this part. Okay, and what you will do, you will simply add up all these. So 32 in 32 plus 16, that should be 48, plus 2, 50, plus 1, 51. So we are going to get only 51 to the base 10, right? But that is not the case here. Okay, if that was the case, then the same process which we have seen in the previous video is sufficient, but we have seen that in practical we use fractional part also, like for say percentages, okay, or let it be CGPA. Fine. So we make use of what is your salary. Suppose somebody will say 12.4 lakhs per annum. So 0.4, we are using a fractional part. So we are taking this example where we are considering the fractional part also. Okay, the non-fractional part, computation is same as what we have seen in the previous case, right? So the way we are going to compute this is, we are going to divide this into 2 parts. Okay, to the left of point, to the right of point. The non-fractional part, we will use the same method, right, as we have seen in the previous video. For the fractional part, that is for this part, we have to do slightly different technique, and that is what we are going to discuss next. So let us see what we are doing for the values to the left of the point. Okay, so what are we doing to the values to the left of point? We are continuously multiplying with 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5 until we are reaching n. Okay, suppose if we had more digits, then we will continue this. Okay, right, we don't have, so we are going to stop with 2 power 5. Now again let us use our logic. When we went to our left, we started in increasing powers of 2. So logically, when from the point, when we go towards right, we have to consider the decreasing powers of 2. 0, if you decrement by 1, 0 minus 1 is minus 1. Then again minus 1 gives minus 2. So we are going in the decrementing power of 2, right? So that is the reason, that is the only thing we need to keep in mind. So very simple, right? So what we are doing, when we are going towards this direction, we are considering the increasing powers of 2 starting from 2 power 0, right. So, when we go in this direction, we have to consider the decreasing power of 2 power 0 already we used. So, we will start using from minus 1, okay, 2 power minus 1 and then 2 power minus 2, fine. Now, what we need to do here is we need to start repeating the same process, that is multiply these to get this, okay, multiply these to get this, right. So, earlier we have already computed this part and we got 51, okay. So, this part we have already done and we got 51, okay, right. So, now we are only going to focus on this fractional part, okay, we are only going to focus on this fractional part. So, what are we going to do here? 1 into 2 power minus 1, 2 power minus 1 is 1 by 2, 2 power minus 1 is 1 by 2, 1 by 2 is 0.5. So, this value is 0.5, 0.5 into 1 gives us 0.5, okay. 2 power minus 2, 2 power minus 2 is 1 by 2 power 2, which is 1 by 4, which is 0.25. So, this value is 0.25, 0.25 into 1 should give us 0.25. So, we are taking 0.25, okay, right. So, what we need to consider is to the previous value of 51, we have to add these two values, we have to add 0.5, we have to add 0.25, okay, right, fine. So, 0.25 plus 0.5 gives us 0.75. So, that 0.75 you can join it here. Earlier you had 51, 51 plus 0.75 should give us 51.75. So, the final answer of conversion of this particular binary number into decimal form is this 51.75 to the base 10. So, we have discussed binary to decimal. So, what will be the next part? Okay, decimal to binary also we need to consider, okay, right. Now, again what we are going to do is we are separately going to calculate the values to the left of point and separately we are going to calculate the values to the right side of point. Now, to the left side of point we have 10. This is same as what we have done in the previous video, that is we are continuously going to divide by 2, okay. So, 10 if you divide by 2 we are going to get, okay, 10 if we divide by 2 then we are going to get the quotient as 5, 10 is divisible by 2, so no remainder, remainder is 0, okay. Then 5 if you divide by 2 then we are going to get quotient 2, remainder is 1, okay. So, 2 2s are 4, so you are going to get a remainder 1. Next, 2 is directly divisible by 2, so we are going to get quotient 1, remainder is 0, okay. 2 if you divide by 1 we are going to get 0 and then 2 into 0 gives us 0, so there is a remainder, right. So, this remainder we are taking here 1, fine. Same as what we did in the previous case, the same method we are going to use for the non-fractional part, which is 10 in this case, okay, right. So, next what we are going to do is we are going to take this like we did in previous case, from bottom to top we are going to consider, okay, and we are going to stop here because we got a 0. We are going to stop and we are taking values from bottom to top. So, 1 0 1 0. So, we are going to write 1 0 1 0, okay, fine. So, that is for the non-fractional part, we have completed that, fine. Next, what about the fractional part? What about the fractional part? Okay, so this is actually 10.625 to the base 10, this one we got, okay, right, these values writing from bottom to top. Now, what about this one? Okay, that is 0.625, we are taking it separately. Previous case also when we considered binary to decimal, right? We have taken the fractional part separately. The same thing we are going to do. Fine. Now here for this one, okay, when we went from left, okay, from point when we went towards the left, we continuously divided by 2. So logically from point when we go towards right, we have to continuously multiply by 2. That is the point we have to keep in mind here. So 0.625 into 2, this step, okay, 0.625 into 2 gives us 1.25. Please calculate and check, it is 1.25. So now what we are going to do is this one we are going to take out, we are going to remove that one, write it on our right side. Remaining what we have 0.25, that we are going to take here, okay. So remaining 0, after taking out the 1 here, 0.25 whatever is remaining, that we are going to write here, okay, fine. And that again we are going to multiply by 2. 0.25 into 2 gives us 0.5. So the same 0 we are going to write down here. We are removing that 0, still no change in the value, okay. So 0.5, that 0.5 we are taking, we are writing it back here, fine. And then 0.5 into 2 gives us 1, okay. Now this 1 if you take out, we are left with 0.0, or simply we are left with 0. Now if you continuously still multiply with 2, you are going to get all zeros hereafter, correct. Hereafter we are going to get all zeros, so we can stop the process here, right. And previous case what we did, we have taken, okay, for the non-fractional part we have taken approach from bottom to top. For the non-fractional part we have taken, okay, the approach from bottom to top, right. So for this one now we will take top to bottom approach. So we have here 1 0 1. So we will take 1 0 1 and that is the end of it. So we are going to stop. So the final result 10.625 to the base 10 is equal to 1010, which we got from this part, okay, right, and 101 which we got from this part. Both we are combining, we are writing here, and that is how you convert a decimal number to binary, okay. So decimal to binary we have seen here. Previous slide, okay, we have seen binary to decimal. What I will ask students to do is try to convert this one back and you should get back this, okay, right, using the techniques which I taught you in the next slide. Then that you can use to verify your answer, right. Likewise, what you can do, the result that you got here, try to compute and get back this result, okay, in your rough column for verification, so that you can be 100% sure that the answer you got is correct. Fine. So in short, we have seen why we need conversion including fractional part, okay, right, and then we have seen the decimal to binary conversion considering the fractional part. Then we have seen binary to decimal conversion, okay, that also considering the fractional part. So that's all for this lecture. Thank you so much.